Welcome everybody to chapter 6. In this video, we will be looking at the introduction to continuous probability distribution. At the end of this video, you will be able to convert a normal distribution to a standard normal distribution. We talked about this in previous chapters. But now we're going to really focus and dive into the whole concept of a standard normal distribution and a normal distribution and how to convert it. If you recall, we learned how to determine the z value and we looked at that transformation. That's where we're heading to right now. And you would also know how to determine probabilities using the standard normal distribution. And I would also show you how to use our statistical software Minitab to solve to solve these problems. And I'll also show you how to use a calculator. And I will show you how to use a table as well from your textbook. And last, you also know how to calculate values of the random variable associated with specified probabilities from a normal distribution. That's the true focus of this chapter. So let's get started. What is a continuous random variable? In the previous chapter, we looked at a discrete random variable. So by continuous random variable here, alternatively, we're saying that which has an infinite range. Okay. Well, before we look, let's talk about normal probability distributions. What's a normal probability distribution? So a normal probability distribution, which is generated from a continuous random variable as opposed to a discrete random variable, is a bell-shaped distribution. So it's a bell-shaped distribution, bell-shaped. Distribution. And by bell-shaped, we're saying that it is symmetrical. So it's symmetrical. And what are the properties of a bell-shaped distribution? One of the properties is that it is unimodal, meaning that there's only one peak. So there's only one peak. So a bell-shaped distribution will look something like this. So this is unimodal, there's only one peak. So the normal distribution peaks at a single value. And that single value, let me redraw this somewhere in the middle here. Okay, kind of looks symmetrical. So we are saying that this side is 50% and this side is 50%. Oops. So it's symmetrical. That's what we're saying, in essence. So this means that these two areas under the curve, this area and this area under the curve, is between the mean. So this center point is the mean, and let's say mu, so population mean, or x bar, which is a sample mean. So it's between the mean and any 2 points. So, and any 2 points here is equal. So let's say this is one standard deviation, negative, -1, this is 1, -2, -3, 2, 3. So this point to this point are equidistant on either side. So the mean, median, and mode are equal. So in this case, the measure of center, the mean is equals to the median, is equals to the mode. All right. So that is the properties of a normal probability distribution. And that is how to draw a normal probability distribution. So from this chapter onwards, we'll be looking at a lot on a normal distribution, because we want the world to be normal. So everything should be normal. And which means that you, at the end of this course, you know how to really draw this curve. This line, by the way, never touches the x-axis. It goes all the way to infinity. So from negative infinity to positive infinity. And this shaded area to the left side is 0.5, and to the right side is 0.5. And at the center, we have the mean is equal to the median and equals to the mode. So that is also the normal distribution shape. So that's the shape. All right. Now, the probabilities that we want to compute are basically the area under this distribution. We want to find the area under this distribution. Okay. And how do we go about this? First, let's assume we have a uniform distribution, which means something like this. So it's uniform. Okay. And let's assume that just give any value. And so let's say I close from work, let's put the value 8. So I spend 8 hours at work, and so at exactly 8 hours from when I start is when I leave, and the maximum amount of time I can spend extra maybe is 1 hour. So this is 9. And let's say the height of this is, so this distance will be 1, right? Now let's assume that this whole area under the curve, the area is equals to 1. If the area is equals to 1, then it means that this height will be equals to what? 1, because the area of a rectangle is the base times the height, which is equals to 1. Now, what if I can spend extra 2 hours at work, and this is 10, and this is 2? If this is 2, to have an area of equals to 1, then this height has to be 0.5. So that's half. And so when we multiply 0.5 by 2, we have 1. So the area under this distribution, this uniform distribution, is equals to 1. It's 100%. So the same idea goes with a normal distribution. The whole area under the distribution is 100%, and what we want to find are different probabilities. So let's say this is 2, and this point here is 9. So let's change this to 9, but the distance is 2. Now, so I have 9 here. So this area here, so the probability of the x is less than 9, less than or equals to 9, will be equals to what? This area to the left. And what's the area? This is now 1 times 0.5, which is 0.5. So that probability is 0.5. And that's the area to the left of this. Sounds good? All right, so if this makes sense, then where we are headed to would make absolute sense. So irrespective of how we draw our normal distribution, so if I draw it's smaller this way, or I draw it's very big this way, or it's even much wider. As long as this is symmetrical, this is the center point, the center point, the center point, this area to the left will always be 50%, and this area to the right is also 50%, 0.5, 0.5. So when we say area, think about probability. So whenever I say the word area, I'm also referring to the word probability. So that is the area under the curve. This area is 50%. This area too is 50%. So we have what I'm showing you here is different normal distributions can be obtained by changing the mean and changing the spread, the standard deviation. So these distributions all might have the same mean, but may have different spread, or definitely has different spread. So changing the mean shifts the distribution left or right. So I can shift, this is at this point, it is shifted to this point, shifted to this point. So let's assume that there was a straight X line. And so this is the location of this distribution. This is the location of this distribution, and that's the location of this distribution. So shifting the mean shifts the distribution either to the left or to the right on this x-axis. Changing the standard deviation increases or decreases the spread. So this has a smaller spread. This has a wider spread. I would say maybe this is medium in between. Okay, so those are the properties. Now, how can we standardize this? It's something we should think about. Now, this distribution x, so the y-axis here is f of x, right? Now, we don't really think much about the function here. I'm going to take you beyond the function, but if I was to express the function that creates the distribution, this is how it is. You know, so f of x is equals to 1 over sigma times the square root of 2 pi. And please don't think about this for the rest of this course. I'm just writing it here for you to see what function creates this density curve. Minus x, let me remember, x minus mu squared over 2 sigma squared here. So in this function, x is any value of the continuous random variable. So x is our continuous random variable. Let me just put for short. Continuous, any value of the continuous random variable. Okay, and our continuous random variable is not discrete this time around, as we saw in the previous chapter. There we were looking at discrete random variable, but here we're looking at a continuous random variable. Examples of continuous random variable will be your height, your weight. Those are continuous random variables. Okay, even temperature is also a continuous random variable, because between 60 Fahrenheit and 61 Fahrenheit, there's a continuous spectrum of values, so 60.1, 60.2, 60.001, and so on and so forth. So that's a continuous random variable. It's not discrete. And sigma, you know, is the population standard deviation. So sigma is the population standard deviation. Now, what is the sample standard deviation? Remember, the sample standard deviation, which we looked at in chapter 3, is just S. Now, you know what pi is. Pi is not the one it's 3.14159. Yeah, about 3. And then E is the base of a natural log, which is about 2.718 and so. And mu, of course, we know is a population mean. Okay, that's this mu, the population mean. Now, so basically, if I was taking into calculus. So let's say we have, this is negative infinity to infinity. The total area will be the integral from negative infinity to infinity of f of x with respect to x, which is actually going to be equals to 1. That's the total area. But that's not what we're looking at in this course. So let me just clean this out so it doesn't confuse you. We're not looking, that's not where we're going to. Let's get back to our normal distributions. So let me draw a much cleaner one. Oh, this looks more very symmetrical, close. All right. Now remember, draw this again. So the center point here is what? The center is the mean, mu. I remember the empirical rule, which we looked at in the previous chapter. We said that one standard deviation from the mean, that will be mu minus 1 sigma. And then 1 is, how many percentage did we say? We said 68% of our data is within 1 standard deviation from the mean. In this chapter, we are going to know the exact value, because then we're looking at using an approximation. We call it the empirical rule. Now, when I show you this in Minitab, you're going to have something like 68.26%, about that. So 68.26% of our data is within 1 standard deviation from the mean. Now, what about 2 standard deviation from the mean, which is mu minus 2 sigma, mu plus 2 sigma? How many percentage of data lies within that? That's about 95.4%. 95.44%. I'm going to show you how to derive that in Minitab as well. Okay, I think I'm writing something different. This is going to be 1. And this is 2. Okay, cool. And then the last one here is mu minus 3 sigma, and then this is mu plus 3 sigma. So it's equidistant from the mean. And that is about 99.74%. Well, how do I know all these values? Because I play with it almost every time. So these are the approximate areas under the normal distribution. Okay. So those are the approximate areas. Now, finding normal probabilities is what we're going to focus on. How do we find the normal probabilities? Because x here, as I said, is a continuous random variable. The probability of x will be approximately 0 for any particular x value. So the probability of a single value of x is equals to any particular value, it will be approximately 0. Okay, and why is that the case? Think about this. Let's come back to this example here. What's the probability that x is equals to 9? That's simply saying the area of this line, the area of the line. And what's the area of the line? The base is 0, the height is 0.5, so 0 times 0.5 is 0. So it's approximately, it's 0. So the area of the line is 0. It's in the same way, in this case, why we said the probability of x is approximately 0 for any particular x, continuous random variable. However, the probability for a range of values between, say, x1 and x2 is defined by the area under the curve between those two areas. So take, for example, if this is, I'll just simply draw, let me see, this one. like I said, in this chapter, we keep drawing a curve. So let's say I drew another one here, and this point here is x1, and this point here is x2. So I want to find the area. So this area is the probability that x1 is less than x is less than x2. So we want to find this probability. So the probability of a range of values between, say, x1 here and x2 is defined by the area under the curve between these two values. So we're going to find this area, and we're going to see how to find this area. Okay, awesome. So what's next? So we've seen what a normal distribution is. Let's talk about a standard normal distribution. How do we convert our normal distribution to a standard normal distribution? Now, for a standard normal distribution, so assuming this is a standard normal distribution, the mean of a standard normal distribution is 0. So if we have a standard normal distribution where this is mean and spread, so the mean is 0, the standard deviation is 1. So the mean is 0, the standard deviation is 1 for a standard normal distribution. So whenever we convert our normal distribution to a standard normal distribution, no matter what the original normal distribution might be, this, or this, when we convert it, we are moving the center all the way to, let's say this is 0.0. So we're moving center to 0, and then we are normalizing the height and everything to look like a normal distribution. Now, with our standard normal distribution, we can then find the probabilities under the curve. Of course, with Minitab, of course, you can always jump certain steps, but let's do this the normal way. Now, our horizontal axis is no more the x-axis, but it's now a z-axis. So sometimes we call this a z distribution. So these values are the z values. And remember, we said the z-score computes the number of standard deviation away a data is from the mean. So these are the z values that measures the number of standard deviations a point is from the mean. So we could have this is 1, 2, 3, -1, -2, -3, and so on. So values above the mean have positive z values. So these are positive. And values below the mean have negative z values. So this will be 1, 2, 3, and this will be -1, -2, and -3. All right. Cool. Okay, so how do we determine these z values? If you recall, I showed you how to determine the z-score previously. So we said that the z is equals to the x value, which would be our continuous random variable, minus the mean divided by the standard deviation. So that's really the trick to finding the probability for a normal distribution. The first thing is to convert the normal distribution to a standard normal distribution. And to convert that, we simply use this expression. We find the z-score. So originally we had the x values, and now we find the z values, and then we can now find the probabilities. Okay, cool. So the z is scaled value. So it's the number of standard deviations a point x is from the mean. And x, as we know, is any point on the horizontal axis. Okay. And let's look at an example. That's the best way to really understand this concept better. So I'm going to pick up an example from the text for us to solve together, and I'll paste the question, which we would solve. So here's a question that we're going to solve right now. So we have the gas mileage for a particular new SUV automobile is normally distributed with a mean of 22 miles per gallon and a standard deviation of 4. Find the probability of one SUV getting between 23 and 27 miles per gallon. So first, let's interpret this question together and create a normal distribution before we find the probabilities. So we're given here that mu is equal to 22. We're also given that the standard deviation is equal to 4. What are we trying to find? We are trying to find the probability of one SUV getting between 23 is less than or equals to X, is less than or equals to 27, is what we are trying to find. So that means that if we have a normal distribution that looks like this, the mean given in the question is 22. But what we're interested in finding, so let's say this is 22, 23, 24, 25, 26, 27. So what we're interested is in finding this area. That's our probability of interest. So our probability of interest is this area. So how do we go about this? I remember that this is X. We've not gone through the standard normal distribution. So what we need to do is to convert these to the standard normal distribution. So we're going to convert for what is 23 in standard normal distribution, what is 27 also in the standard normal distribution. So that's what we're going to do first. So Z is equals to, remember, X minus mu divided by sigma. I can assure you this, if you write this 10 times, you remember this for the rest of your life. So this is going to be, for the first one, we have 23 minus the mean is 22 divided by sigma, which is 4. And this will be 1 divided by 4, which is 0.25. Okay. And then the next one, Z, is 27 minus 22 divided by 4. So this first value, 23, is 0.25 standard deviation away from the mean. That's what it means. And then this second one would be 27 minus 22. That is 4. That is so that's 5. So that's 5 divided by 4, and that is 1.25. Okay, cool. So what we have done here, now we have transformed these to our standard normal distribution. Doesn't look so normal. Okay, I'll go with this. And what we have here is that the center here is 0. And let's say this is 1 standard deviation from the mean, 2 standard deviation, 3 standard deviation. If that's the case, what we're looking at here is 0.25, which will be somewhere around here, all the way to all the way to 1.25, which will be somewhere around here, considering that this is 1, 2, 3. And that means that our area of interest is this. So this is our probability of interest. So that's the area we want to find. Okay, so we have 0.25 and we have 1.25. 1.25, and we need to find that probability. So how do we go about solving this? So there are many ways. We can use a standard normal distribution table, which you would find in your textbook. So I'm going to bring up the standard normal distribution table to explain how to read it. So let me bring that up. Okay. All right. So here is the standard normal distribution table. And of course, there are various tables you will find on the internet for when you go on the internet and you search for a Z table. You can find several Z tables on the internet. While that is opening, let me get back here. So let me explain this one that we have here. So this Z table, this standard normal distribution table that you find in the appendices of your textbook, only gives us the probabilities of that are the positive probabilities from 0 towards the right. So they give an example here. So the example that is given here is that assuming that Z is equals to 1.25, now, and I think in our problem, we have a case of 1.25 as well. So one of our probabilities is from 0.25 to 1.25. So if we're looking for the probability between 0 to 1.25, which should be a little bit more than what we want to get for our own problem, using this table, how do we interpret it? So 1.25 would be the Z value is 1.2, then 5 to look at the column. So the row here, you look for 1.2 at the column, 0.05. So that's 1.25. And we have 0.3944. So this gives us the cumulative probabilities, okay, from 0 to 1.025. Now, if we want to, for our own problem, we need to also know what 0.25 is. So how do we know 0.25? So here we have 0.25 would be, so we have 0.2 and then 5 will be this. So that would be 0.25, which is 0.0987, 0.0987. Okay. So I would write this down. So we have 0.0987, and what you're going to do is subtract these from 0.0987, and that's how we are going to solve the problem. Okay. All right. Sounds good. So that's how to go about it. Now, of course, doing this in Minitab might be much easier. Like I said, I'm going to focus on Minitab. Now, in Minitab, this is what we do. We click on graph, you go to probability distribution, view probability, you click OK, and change this to a normal distribution. In the last chapter, we looked at binomial. Now we are coming back to the normal distribution, and set your mean and set to 0 and standard deviation to 1. That makes this a standard normal distribution. And now in the shaded area, we would change this to X values. And let's say we want to we click on the middle, since we have a range of values we want to find in between. So our left will be 0.25, and to the right will be 1.25. And now when you press OK, this gives us the probability of interest. So remember, when we looked at the table to the right, we had from 0 to 1.25, we had about 0.3925. And then at from 0 to 0.25, we had something about 0.0948. Now, when you subtract both of them, those numbers, you will have 0.29, about 0.2956. Now, if this is not clear, we have the student hours, which you can make use of, and I'm happy to explain this much further to you. So you can always reach out to me at any time if you have questions. Let me bring back our board. Okay, so that's how to interpret the table that you have at the back of your textbook. So what we found here is that the probability that 0 is less than z is less than 0.25 was about 0.0948 about that. And then the probability that 0 is less than z is less than 1.25 was about 0.3925. And of course, you can always verify this from what we just did. And what we need to find is to subtract this from this. So the probability that 0.25 is less than z is less than 1.25 would be the difference between 0.3925 minus 0.0948. Now, this might not be exactly as that which we have in Minitab, but it's very close. So this would be 0.2977. All right, so it's about that. Yes, so now you know how to find the probability under a standard normal distribution. So we know that this shaded area is 0.2977, about that. And we also saw that from Minitab as well. Okay, so let's see. What do we have next? So we have seen how to find. So given the z values that we just found, we know how to find the area. Okay, so given that you know what the z value is, and how do you determine the z value? We determine the z value from knowing the x values. So, and we used this expression to determine the z value. And I think let's look at one more example to make this much more clearer. So let's look at a different example. I'm going to paste the question here for us. So in this question, let's say the tips left by customers at a local restaurant are normally distributed with a mean of $12. So the mean mu is equal to 12 and a standard deviation of $3. As you can see, the units of the mean and the standard deviation are the same. Okay. Now, what are we to find? Find the probability that the customer will leave a tip of less than $8, of less than $8. So this is saying the probability that X is less than or equals to 8. So what is this probability? We can draw this out so we can visualize what we are trying to solve. What's the mean? The mean is 12. That's the center point. Now, let's say this is 12, 11, 10, 9, 8. So if this is 8, so we are looking for these probability to the left from negative infinity all the way to 8. Okay. So if I was to bring that expression, negative infinity to 8, f of x, with respect to x. Okay, we're not dealing with calculus. I'm just trying to scare you a little bit. All right, so this is the probability of interest. That's what we want to find. How do we go about solving this? Okay. Now, remember in the table that I showed you from the textbook, we only have positive values. So we can now look for the values to the right of it. So if this is, so we find the z value of this, and then we find the probability to the right using the table. So first, we need to convert this to our standard normal distribution. So what is the z value? So that would be x is 8 minus 12 divided by 3. Okay? So what is that? So what's 12? 8 minus 12? 8 minus 12 is what? Is negative 4, right? So that will be negative 4 divided by 3. Now you can pick up your calculator to do that. Four divided by 3, that's 1.33333. So that will be negative 1.33. Let's put it to decimal places. So what we are saying here is that we now have a standard normal distribution in which the center point here is 0. And let's say this is one standard deviation from the mean. And this is 1.33. So we're interested in this area. So this is negative 1.33. So if this is negative 1.33 to the right, this will be 1.33 as well. So this area here would also be equals to this area to the right. Isn't it? Cool. Now, that means that in order to find this area, and of course, when I said this is 1, this does not really look, 1 should be somewhere close to 0. So in order to find this area, we need to find this area first. So the table given to you in your textbook gives you the area from 0 to 1.33. Now, when you know the area from 0 to 1.33, how do you find this other area? How do you find it? How do you find this area? Remember that the area to the right here is 50%, is 0.5. So if you know this area in blue, you subtract this area from 0.5, and that will give you the area in red. And that is the area that is of interest. That's how you use the table. I don't want to bring back the table right now, but I'm just trying to show you visually and how you go about solving this. But I'm going to show you the easy way out using Minitab. So let's bring up Minitab to solve for this problem. So there is Minitab. I can go back to the last activity I did. Normal distribution, rates, shaded area. This time around, we're looking for the area to the left. So we click on left tail. And what is our value? Our x, as this time around, it's going to be the z value. Even though it's written x value, think of it as a z value since this is a standard normal distribution. Okay. So this will be negative 1.33, and then you click OK. And there you have it. The probability of interest is 0.09176. Of course, you can also use your calculator to do that. Let me not forget the calculator. So we go here, second function, bar, press turn on the calculator. Okay. Okay, Our calculator is on. Second function verb that takes us to the distributions. We are dealing with a normal distribution, but this time around the cumulative distribution. And because the PDF will give us just for an exact value. So we're looking at the CDF. So you click OK here. Now we're going from negative infinity to negative 1.33. Now it's already giving us a very small number to the left negative. Now we said that anything less than negative 3 is unusual. So we can change this to say negative 100. Negative 100. Or you can use the number that you saw there. That's fine. And now let's take it down. So our upper point will be negative 1.33. And our mean is 0. Our standard deviation is 1. And now we paste this and press enter. What do we have? 0.197591981. And this is rounded to 0.09176. So you see, we got the same thing. Awesome. Okay, okie dokie. How you feeling? Feeling good? I feel good. And of course, if this was your lab, you can copy the graph and send it to your Word document and properly caption your figure in order to submit your reports for your labs. So you can see how easy it is to do with Minitab. It's visually appealing. You can really see what you're doing, the area of interest, as we have drawn on paper. And so either way, you can play around with this. Either you choose to use a calculator, you choose to use Minitab, or you choose to use a table. Either way, you will get to the same solution. So let's get back our board. And so what we just did, we just found the probability of interest. So we found the probability that Z is less than or equals to negative 1.33. And what did we find that to be? We said it was about 0.0918. So for decimal places, let me confirm. 0.0918. Yeah. Awesome. And of course, as I said, you can use a table, finally, I think our Z tables are up. Yeah, that's my email if you want to reach out to me. Okay, so we have this Z table, so you can click on it and also play around seeing how you can interpret any of these tables. So there are different types of tables which you can find, or you can simply use the one with the table given in the textbook. All right, my friends, let's bring back the board. Sweet. So with these, now you know how to find the probability, or you know how to find the area. Good. So next, let's look at something different. So how do you find the z-scores from the area? So we knew the z-scores and we found the area. Now, what if you're given the area? How do you find the z-score? So this is now the inverse. And from areas, referring to from the probability. So you know the probability. How do you now find the area? Okay. So let's look at this example here. Let's say, so the first thing first you do is you draw the picture, which is the distribution. And then you use a table or the calculator or Minitab in reverse. So I'll do this a little bit quickly. So let's say we have the distribution and we want to find the z-score that represents the bottom 95% of the data. So by bottom 95%, let's assume that this whole area to the left is 95%, which means that this area is what? 5%. Okay. So we want to find the probability in which, so if this is our standard normal distribution and this is 0, so we want to find, and this is our z distribution, so we want to find the probability in which z, so let's say this is z1, that is what we're trying to find. So z1 again, the probability in which z is less than or equals to z1, which is what we're trying to find, which is equals to 0.95. So what is that? What is z1? How do we determine z1? All right. So I'm going to show you this with a calculator, and I'll also show you with Minitab. So with your calculator, let's bring up the calculator. We are going to go back again to second function var, but first turn on this calculator. Okay. Second function var. And this time around, we're going to use the inverse norm. The inverse norm. So you press enter. Now, what's the area? 0.95. We're dealing with a standard normal distribution here. So just press enter, press enter, press enter, press enter, press enter. And that gives us 1.645. To 3 decimal places, 1.645. Okay. Sweet. So let's bring back our board. Let's verify that from Minitab. We have 1.645. I'll bring Minitab. So in Minitab, I'll click on my last operation. So that brings this up, shaded area. Left tail of, this time around, we're going to change this to probability. So we're given the area, we want to find the z value. So, and also the left tail. And so we're given a probability value of 0.95. And then you press OK here. And you can see that as z value is 1.645. That's exactly what we got with our calculator. So the inverse norm, that's the way to go. Awesome. Get back our board. Where are you? All right, there you go. So Z1 is equals to, is approximately 1.645. So given the z-scores, find the area. And basically, I'm going to give you all a take-home assignments for you to do and try yourself. So I've shown you these, and I believe you can do the rest, either using the calculator or using Minitab. And if you have any questions on these, you can meet with me during our student hours, and I'm happy to further address these concepts. So the challenge question for you all is to find the top 30%, the bottom 10%, the top 70%. So what I'm saying here is when I say the top 30%, what it means here is you have this distribution here, and the top 30% here with 0.3. If this is 0.3, it means that this area is what? 0.7. And all we're interested in is this Z value, this Z value. So what is that Z value? And now if I say the top 10%, I mean the bottom 10%, so what we're saying here is that at this point here is 0.1, 0.1, and then this area here is going to be 0.9. We're interested again in this point. So what is that Z value? And if I say the top 70%, so what we're saying here is that this whole area is 0.7 and this area is 0.3. If you look at it, this and this is kind of symmetrical. So if whatever I get here, what I would have here will be the negative value of it, because this area is 0.3, this area is 0.3. So this Z value and this Z value are equidistant from the mean, which is 0. Okay, so that's the interpretation, that's the visual representation, that's the way to go. All right, so now you know how to find the Z values or the Z scores from the area. Awesome. And just for fun, let's bring back Minitab. Now, let's find some Z values. So remember the empirical rule we looked at, we said that one standard deviation from the mean. So we looked at a Z score, and in a Z score, let's say the middle goes from -1 to +1. We said that 68% of our data lies between one standard deviation from the mean. So let's see what exactly that is. That's about 68.27%. See? Now let's look at two standard deviation from the mean. So this is -2, this is +2. Press OK. That's about 95.45%. So that of 95.45% of our data lies within two standard deviation from the mean. Now, what about 3 standard deviation from the mean? Let's see the exact value. So these values I'm entering here are the Z values. And there we have it. So 99.73. Cool. I think it's cool. Now, if I ask you to find the Z scores that gives the area between the top 25% and the bottom 25%, how would we go about it? Okay, so I'm going to show you in Minitab, since we're right here in Minitab. I'll bring back this last operation, and this time around, take it back to probability. Now, towards the left side, we're trying to find the Z values, but the left area is 0.025 and the right area is 0.025. How do we go about it? If you look at this one, it has both tails. So to the left tail, so we use this. So to the left tail is 0.025. So the right tail is 0.025. So if you add both of them together, what does that give us? That gives us 0.05. Okay, so we enter here 0.05, and that will divide these into both tails. So one tail will be 0.05 0.025, and the other tail will be 0.025. And if you click OK, we have that the Z value is negative 1.96, 1.96. So if this is 0.025, 0.025, what's this area in between? That's the 95%. And did we do it already? Yeah. So 95%, which is 95, is about -2 to +2. So if we're looking at exactly 95% of our data, then it's the Z value is not -2 and 2, but actually 1.96. Okay, it's actually 1.96. Well, we simply just approximately to 2. So when we say 95% of our data is in the normal range, as is usual, and that which is unusual is more than 2 standard deviations from the mean, the actual value is 1.96, negative 1.96. Sounds good, everybody? Fantastic. So you can walk in both directions. So given the Z values, you know how to find the area, and given the area, you also know how to find the Z values. Good. And so this is really everything about this chapter. The rest is for you to keep on solving more problems. The more problems you solve, the much easier it will be. So I really would recommend that you play around with everything that we've covered in this video, and practice makes you better. The more you practice, the better you'll become. The more problems you solve, the easier this whole concept will be. And of course, in your homework assignments, you have various applications on how. I have given you problems that shows you the applications of this topic. So the standard, what we've learned so far in this video is a standard normal distribution, how to find the probabilities from the standard normal distribution using the Z-score, and how to use a calculator, how to use a table, how to use Minitab. So we sure have covered quite a lot. And at this point in time, I'm going to end this video. So in the next chapter, we'll be looking at, which is chapter 7, we'll be looking at sampling distributions and the central limit theorem, and which is really the fun part of this whole course. So I wish you all a beautiful rest of your day, whatever time you're watching this video. Bye for now.